Alright guys, it's time for the next section, 11.2, solving exponential equations using logarithms. So to be able to do this, we really just need a quick review on some of the log properties. So recall the log properties. Alright, so little a, remember what was the first one? We said log of 10 raised to the n equals n. Little b, we said 10 raised to the log of n equals n. Little c, we said the log of a times b is equal to log of a plus log of b. Then we said log of a divided by b is equal to log of a minus the log of b. Little e, we said the log of b to the t is equal to t times log of b. And this one is probably the one you're going to use the most, so you got to make sure you know it. And then finally the last one, little f, log of 1 equals 0. Okay, so those are the properties we're going to use. So now we'll just run through a bunch of examples out of the book. Alright, so big 2, some examples. Let's see. And we want to solve each. Or well, let's do it like this. Little a, solve each equation. Alright, the first one we'll solve is number 13 out of the text. This one says 2 raised to the p equals 90. Okay, well when you're solving these, you basically want to get the the variable term by itself. So we have that here. We have 2 to the p equals 90. 2 to the p is the variable term. So to undo the exponent, we have to apply a logarithm. So the idea is you apply log to each side. So by doing this, this gives us log of 2 raised to the p equals log of 90. Okay, then we use this fifth property up here to get the exponent off of the 2. So this becomes p times log of 2 equals log of 90. Alright, now what you need to make sure you understand is that log of 90 is a number and log of 2 is just a number. They're just numbers hidden in the calculator for the most part. So we divide each side by log of 2. I'll move up a little bit. So that means p equals log of 90 divided by log of 2, which is the exact answer. So this is the exact answer. Alright, but then if we want a decimal, then after you get the exact answer, then you can plug it in your calculator and you get p equals, let's see, log of 90 divided by log of 2. You get 6.4919. Okay, so this is the non-exact answer. That's the rounded answer. Okay, now let's try number 22. Okay, let's try number 22. This one says 5 times 2 raised to the p equals 90. Okay, so again, we want to try to get the variable term by itself. So here 2 to the p is going to be the variable term. So to be able to get that by itself, you have to divide by 5. Divide by 5. So the 5's cancel on the left, so I'm left with 2 to the p. And then 90 divided by 5 is 18. So now we apply log to each side to get log of 2 to the p equals log of 18. Use that fifth property to get that exponent off. P times log of 2 equals log of 18 divided by log of 2. And we're left with P equals log of 18 divided by log of 2. And this is your exact answer. And if we want to get the decimal approximation after getting the exact answer, we plug that in our calculator and we get 4.1699. Okay, so if you're asked for an exact answer here, if you're told you can round, you can use that one. All right, how about number 25 now? See, number 25 says 8 times 2/3 raised to the t equals 20. All right, so you have to know what your variable part is. Here's our variable part. So that means we want to divide by 8. 8's on the left cancel, so I'm left with 2/3 to the t equals 20 divided by 8 reduces to 5/2. We apply logs again to get this exponent off. So we end up with t times log of 2/3 equals log of 5/2. And then we divide by log of 2/3. Those cancel on the left, so I'm left with t equals log of 5/2 divided by log of 2/3. And this is your exact answer. But if you want a decimal, log of, let's see, 5/2 divided by log of 2/3 gives us negative 2.2599. And this is your approximate answer. Okay, so that's all solving the exponential equations. All right, now let's try to solve a logarithmic equation. So remember from the previous section, we learned that logarithms and exponentials are inverses of one another. So we use logs to solve exponentials. So now when I try to solve, let's say this is going to be number 4, little 4, number 46, this is a log equation. 2 times log of x minus 1 equals 9. So here we want to get the log portion by itself, which is that. So to do that, first we have to divide each side by 2. So we have log of x minus 1 equals 9/2. Then we need to add 1 to each side. So that means log of x equals 11/2. So now what we do to undo log, we have to raise each side to whatever the base is. So remember, this is the common log. So what we do is we raise each side by 10. So we do 10 to the log of x equals 10 to the 11/2. Now if you remember from one of your properties, 10 raised to the log of x is simply x. So we get x equals 10 to the 11/2. Now this is going to be your exact answer. Alright, but if we want an approximation, we can plug it in the calculator. It's 10 raised to the 11 divided by 2 is 316,227.766. And this would be your approximate answer. Okay, so now how about, let's see, let's try a different one. Instead of solving little b, here's another question. Here's a different question. Do you need logs to solve the following? So first, let's look at number 49. 10 squared times x equals 10 cubed plus 10 squared. Okay, so remember, you need logs when you're solving exponential equations. So the real question is this an exponential? And the answer to that is no. This is not an exponential equation because this is a number, 10 cubed plus 10 squared. 10 squared is simply a number, and your variable term is simply down here. So the correct answer is, since x is not in an exponent, no logs are needed. Okay, that's simple. All right, let's try another one like this, little 2. Number 51 says 2 raised to the x plus 1 minus 3 equals 0. So is this an exponential equation? And the answer to that is yes, because we have an x in the exponent. So since x is in the exponent, logs will be needed. That's simple. Okay, so now I have one more problem for you to solve, and it's a bit of a doozy. It takes a lot of algebra. That's why we're going to go through it. And this would be little c. This is number 62. So number 62 in the book says the amount of contamination remaining in 2 different wells T days after a chemical spill in parts per billion is given by R of T equals 320 times 0.94 to the T, and S of T equals 540 times 0.91 to the T. And we want to solve the equation R of T equals S of T. All right, so we have R of T equals 320 times 0.94 to the T, and S of T equals 540 times 0.91 to the T. So we want to solve R of T equals S of T, and this is really not that hard. So first you set the right hand sides equal to one another. 320 times 0.94 to the T equals 540 times 0.91 to the T. So what we want to do is we want to bring the variable terms to each other and the constant terms to each other. So I'm going to start by dividing by 540. So on the right they cancel. So on the right I have 0.91 to the T. On the left, 320 divided by 540 reduces to 16 over 27 times 0.94 to the T. Now divide by the 0.94 to the T. That cancels on the left, so we have 16 over 27 equals 0.91 to the T divided by 0.94 to the T. Now if you recall, back in chapter 6, if I had a to the x over b to the x, I could write that as a over b to the x, and that's what we need to do here to be able to solve this one. So let me move this up. This is going to be 16 over 27, 27 equals 0.91 divided by 0.94 to the T. So now that I have just one exponent, I can apply logs. So log of 16 divided by 27 equals T times log of 0.91 divided by 0.94. All I did here was, after I applied log, I used one of those rules. And now we just divide by this number. So we're going to get T equals log of 16 divided by 27 divided by log 0.91 divided by 0.94. And when we plug this in our calculator, we get 16.1321. And this is in years. So the idea here is, after 16.1321 years, the wells have the same amount of contamination. Okay, I hope you guys enjoyed it. I'll see you in class tomorrow.